Namaste everyone.
Namaste, sir.
Namaste, sir.
Namaste, sir.
Good morning, sir.
Morning. Namaste everyone. So let's continue with the revision of physics part. So yesterday evening, we have discussed the reflection part in the light chapter. Right now, we are going to discuss the refraction part. Okay. See, once you have understood the reflection part, the refraction becomes really easy. Okay. Because almost all the rules which we have learned in reflection, right? Okay, the same rules will be applied here also. Obviously, some terms will change, but majority of the rules are going to remain the same. Okay. So let me share my screen. So now, suppose I have a glass of water. Okay. Suppose I have a glass of water. So you can see there is actually a very thin layer. So I'm talking about this layer. See, there is a very thin layer, that is this layer, which is separating both air and water. So if I take a glass of water, above fully air is there and below we have water, right? Yes. So there is a very thin line which separates air and water. Okay. That thin line which is going to separate any two medium. What is medium? Medium is a substance through which light travels. Okay. So here one of the medium is air, the other medium is water. Okay. Here I've got two medium, air and water. Medium is a substance through which light travels. So now there is a very thin line which is separating the two medium. That thin line is called as interface. Okay. So please remember, a very thin line, it's an imaginary line which we are assuming, which is separating two medium, that is actually called as interface. Okay. Now, if you compare air and water, air and water, in water, the molecules will be more closely packed compared to air. If you compare the water molecules and the air molecules, in between the two, in water, the molecules will be tightly packed. It will be close also. Correct? So we can say that as compared to water, as compared to air, water is going to be denser. If you compare water with respect to air, water is going to be denser. Okay. Now suppose instead of suppose at the top I have glass. Okay. Suppose the two mediums are glass and water. Okay. There is an interface here. Suppose here I have glass, here I have water. For example, now if you compare water with respect to glass, water will become rarer. Okay. So this rarer and denser, no, they are relative terms. Water need not always be denser. It may be rarer based on what you're comparing with. So if you're comparing water with respect to glass, water is going to become rarer. Now here in this particular case, we are comparing water with respect to air. That is why it is denser. So this is a denser medium. This is a rarer medium. Okay. So now when light is traveling in any particular medium, for example, air or water or glass or kerosene oil, when light travels in any medium, it is a property of light we have studied last class that it always travels in a straight line. So in any particular medium, light will always travel in a straight line. So you can see here, light is traveling in a straight line. Okay. In air, light is traveling in a straight line. See, if this glass of water was not there, light would have gone in a straight line. If this water was not there, light would have gone in a straight line like this. It would have gone in a straight line like this. Okay. Light would have gone in a straight line. But because there is a change in the medium, see, if fully air was there, light would have gone in a straight line. But whenever there is a change in the medium, just give me 1 minute. Okay. So if fully air was there, like here also if air was there, light would have gone in a straight line. But because of the change in the medium, the speed of light is going to change. Okay, because in every medium, light is going to travel with a particular speed. In air, it will travel with some speed. In water, it will travel with a different speed. For example, in some other medium, for example, kerosene, it will travel with a different speed. So when the medium is going to change, the speed of light is going to change. Okay. And as a result, there is bending of light. See, light was supposed to go in a straight line, but because of the change in the medium, the speed of light changes. And as a result, light is actually bending. See, light is going now like this. Light is going like this. It was supposed to go in a straight line, but now it is going like this. Okay. So this phenomenon of bending of light, when it travels from one medium to another, and why is this, like, why is actually the path changing? Because the medium is changing, and when the medium changes, the speed also changes. Okay, see, I've given all the definitions. First of all, you try to understand the concept. What is refraction? Okay, so this change in path, of light when it's traveling, that is this phenomenon is known as refraction of light. Okay, so just 1 minute. So now here, what is refraction? The bending of light when it passes from one medium to another due to the change in the speed of light is actually called as refraction of light. Okay. Now it has been found that when light travels from a rarer medium to a denser medium, see, light is actually traveling from a rarer. Okay, if you look here, light is traveling from a rarer medium to a denser medium. See, it is coming from here, no? So it is traveling from rarer. Okay. So how do you know it is rarer? Because if you compare air and water, air is rarer, water is denser. So when light is traveling from a rarer medium to a denser medium, it has been found that it will bend towards the normal. And please remember, normal, in the case of refraction, right? Normal, we are going to draw to the interface and at the point of incidence. I repeat, where will you draw the normal? At the point of incidence. This is the point of incidence. This is the point of incidence. So normal we are going to draw here and to the interface. This is the interface, right? This is a line which is separating both air and water. So normal we are going to draw at the point of incidence and to the interface. And please remember, normal, as I said last class, is always by dotted lines. Please draw normal only by dotted lines. Some people know in the answer sheet I have seen they're putting straight lines. Normal always, please put dotted lines, okay? So when light is traveling from a rarer medium to a denser medium, it is going to bend towards the normal. See, originally light would have gone in a straight line. Originally light would have gone in a straight line. Where is the bending taking place? Bending is taking place in this particular medium, right? Because here light will travel in a straight line. It's air. Bending will take place here because there's a change in the medium. And because of change in medium, speed of light will also change. Yes. So now it was supposed to go like this, but it will come towards the normal. See, this light was supposed to go like this. It will come towards the normal. It is coming towards. It is coming towards this one. This is normal, right? This is normal, right? It is coming towards. Okay. So this is the refracted ray. This is the incident ray. This is the incident ray, and this is a refracted ray. Whenever you're drawing a ray, please put the arrow. Arrow is mandatory because it will show the direction in which the light is coming. Okay. So incident ray and then refracted ray. Okay. And the angle between the incident ray and the normal, and incident ray and the normal, this is the angle of incidence, and the angle between the refracted ray is a refracted ray and the normal, that is angle of refraction. Okay. Angle of refraction. Okay. Now if you look here, light is coming from glass and going to water. So if you compare glass and water, glass is going to be denser. So when light travels from a denser medium to a rarer medium, it will bend away from the normal. See, light was supposed to go like this in a straight line. It is going away from normal. Normal is this, away from normal. Okay. So please remember, whether it is towards normal or away from normal, we are going to measure with respect to original path. Please remember, towards the normal and away from normal, we are going to measure with respect to what? Original path. This was the original path. Towards the normal means it will be like this. Away from the normal, this was the original path. Away means it will be like this. Normal, away. This is normal, towards normal. Okay, so please remember that. Okay, so when light travels from a rarer medium to a denser medium, it bends towards the normal. And when light travels from a denser to a rarer, it is going to bend away from the normal. Okay, and you have understood the phenomenon of refraction of light. See, here also same thing I have actually explained. Okay. Next, we have laws of refraction. Please learn the laws as it is given in the textbook. I've actually picked this from the textbook only. Okay, so whatever definitions I have given in class notes, right? You can write those itself. Okay, you don't have to look in textbook and all. You can just use this laws of refraction. So the first law is the incident ray. the refracted ray and the normal to the interface of the two transparent media at the point of incident all lie in the same plane. See, transparent media means through which you can see. Okay, you should be able to see through that. And media, you understood, like it's a, like they have used actually the plural word medium, media, like that. Okay. So now the incident ray, the refractor and the normal all are actually going to lie in the same plane. Next, the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This is also known as Snell's law of refraction. Sometimes they're asking what is Snell's law. So Snell's law is only this one. From here to here, you're right. Okay. The ratio of sine of the sine of angle of incidence to the sine of angle of refraction is a constant for a light of given color and for a given pair of media. This is known as Snell's law of refraction. And this is true only for angle of incidence. I is what? Angle of incidence greater than 0 and less than 90. Okay. So now actually from this particular law, right, the Snell's law, they ask questions based on refractive index, sometimes for 5 marks. Okay. You can look at the previous year papers. You will find that sometimes they are testing 5 marks from this topic itself. So here we have a concept of refractive index. So you have to be very thorough with this. Okay. Okay. My voice is low. Am I audible, everyone? Yes or no in the chat box? Vaishnavi, can you just increase your volume? Maybe I think so. My audio should be very clear. Are you all able to hear yes or no in the chat box clearly? Or is it very low? Like I have got a message that my voice is very low. Okay, everyone else is able to hear. Okay, perfect. So Vaishnavi, yes, thank you. Thank you, everyone. So Vaishnavi, just try to increase the volume. You'll actually get it. Okay. Yeah. Thank you. Thank you, everyone. So we'll actually be discussing this second law in detail later on. As of now, we'll actually give a pause to this. Okay. We'll discuss this for sure. Okay. And we'll also discuss some numericals on refractive index. Actually, I had discussed during regular classes. I had discussed that in the 10th lecture. 10th lecture was taken on 25th of March 2024. So I had discussed that particular concept of refractive index. We'll do that. Okay. First, let's see the ray diagrams for like the lenses. Okay. So we have basically two kinds of lenses. One is convex lens, another is concave lens. Now they're asking differences between the two lenses in the exam. See, as of now, by looking at the lenses, we can say that convex lens is thicker in the middle and thinner at the edges. Okay. Concave lens is thinner in the middle and thicker at the edges. That is the only thing we can see as of now. But as we learn the ray diagrams, you will be able to write few more differences. Okay. As we see the ray diagrams, you'll be able to write few more differences. Okay. So a convex lens is thick at the center but thinner at the edges, and concave lens is thin in the middle but thicker at the edges. I have shown the diagram here. Look here. Convex lens and concave lens. Okay. Now, if you take a concave lens or a convex lens, see, it'll have a center, right? This point. That is the central point of the lens is known as the optical center. Okay. So we'll discuss few terms. Okay, as to what is optical center, I've given all the definition here. The central point of a lens is known as optical center. See, in our diagrams, right, we are going to represent lens like this, convex like this, concave like this. Okay. See, this is how a lens looks like, convex and concave. Okay. But we are going to represent this way in the ray diagrams. Okay. Now, one more request. Whenever you're drawing the lenses, right, please mark the optical center somewhere in the middle, exactly in the middle. Don't use that much thick line. I mean, you have to make your pencil very sharp. So this is going to be the optical center. And you please put one dotted line here. It will make your diagram look better. Anyway, we'll discuss all this while drawing the ray diagram. You draw the central point. So central point is central. This is the central point, center of the lens. Like this. Okay. So now, if you look at the convex lens, let's see the convex lens. Now when you go to higher classes, now you also have this kind of lenses, plano-convex. That means one side it will be plane, another side will be convex. It will be bulging out. Next, we have plano-concave also. One side will be plane, another side will be concave. So all these things is not there in syllabus, don't worry. Okay, see, our main focus in today's class will be only to see some important concepts and do questions. Okay, we will not focus, like we'll not dive into that much depth with the basics. Okay, I have already taught all these things in regular classes, so I don't want to actually again repeat all this, okay? See, Swayam, we can know whether a medium is rarer or denser just by comparing. I mean, we need a value of refractive index basically. So when I come to refractive index, that time we'll come to know. So refractive index basically represents the optical density of a medium. So through that only we can come to know. But see, generally they will not ask those kind of questions, which is rarer, which is denser. If they ask also, they will give you the refractive index. So based on the refractive index only, we'll be able to compare. So for example, they say refractive index of water is maybe 1.33 and refractive index of glass is 1.5. For example, I'm saying. So if you compare these two, refractive index here is higher. So this is having, this is actually denser, optically denser compared to this. This is denser, this is rarer. If this is water and this is maybe like glass. Okay. So if you compare both of them, they will give some values. Okay. They will not randomly ask. So we can say that glass is optically denser compared to water. Clear, Swayam?
Yes, sir.
Okay. Let's move forward. So now if you take a look at the convex lens, see convex lens is also called as a double convex lens. So if they give in the question paper double convex, please don't get confused. Okay, both the sides is convex, right? So that is why it is called as a double convex lens. So if you take a double convex lens, it is having spherical surface on both the sides, right? So if you take a look at this part, okay, if you take a look at this part, see this part we can extend, you'll get a sphere. Yes, you look at a sphere. That sphere will have a center. This is a center basically. The sphere will have a center. That is a center. And now, if you take a look at this part, again you can draw a sphere. That will also have a center. Now in lenses, no, we don't use center of curvature word, okay? We don't use those things, okay? We use F1 and 2F1. Basically, this is only center of curvature, basically, okay? But we don't use C in the lenses part. Please don't use C there. So we know, right, R is equal to 2F. See, we know, right, R is equal to 2F. So for thin lenses, for thin lenses, okay, again, here also R is equal to 2F. For thin lenses also R is equal to 2F. So that means this point is exactly 2F, right? That is why we write 2F1. See, up to here it's F1 and this is another F, right? If this is F, this will also be F. That means from here to here it will be 2F. That is why we write 2F1. So F1 and 2F1. Okay. So up to here, it is F1 and F2 and same way. So F1 and 2F1, sorry, F1 and 2F1, here F2 and 2F2. Okay. Why are we using F1, F2 and all? Because there are two spherical surfaces, so there will be two focus. Because there are two spherical surfaces, so we'll have two focus. One on the left side and one on the right side. Okay, there will be two focus. Okay. Now, in our syllabus, every time the object is going to be kept only on left side. Please remember, in our syllabus, we are going to keep the object always on the left side only, left side. Okay. So light rays are going to come from the object from the left side only. Please remember. And since we are going to place object on the left side, object distance is always going to be negative. We have already discussed last class. Object distance will always be negative. Okay. So there'll be two focus here. One on the left side, one on the right side. Okay. And then we have F1, 2F1, F2, 2F2. Please remember. Okay. So now how do we draw lenses? Again, see, actually you can take a compass, you can choose any radius and maybe draw one arc, okay? And go to the other side, draw another arc. So that it is intersecting. So you'll get the lens, okay? After getting the lens, no, you draw a straight line, okay? That straight line should pass to the center, okay? So this is optical center, okay? And then join dotted line like this. Please don't use this much thick lines. You have to use very thin lines. You have to sharpen your pencil. Okay. Now, this is optical center, right? This is optical center, right? So from here, measure 2 centimeter, mark F1. Another 2 centimeter, mark 2F1. Same way, F2, you measure 2 centimeter, another 2 centimeter, mark 2F2. Okay. So whenever you're drawing ray diagram, please finish all this first. First, draw the lens, mark the optical center. This is O. Optical center is O. From here, 2 centimeter. Irrespective of whatever is the focal length, you please choose 2, 2. It will be much easier for you to draw the ray diagram. Irrespective of whatever values they have given, we cannot actually see if they tell the focal length is 20. I mean, we cannot choose focal length 20 here. It will go out of the page, right? So please take 2 centimeter and then draw the ray diagram. It will come properly. And for object height, you can choose 1.5. Whatever object height they have given, you have to choose 1.5 or maybe 2 centimeter also you can choose. But for when you're placing the object at center of curvature, right? You choose 1 centimeter, please remember, to be able to get a perfect diagram. Okay. So these are all the definitions. The central point of a lens is called as the optical center. An imaginary straight line passing through the two center of curvature is actually called as principal axis. The effective diameter of the circular outline of the spherical lens is called as aperture. So aperture is actually from here to here. This is actually aperture. Okay, from here to the, okay. I mean, I'm not showing properly. It's through the center, okay, like this. Okay. So effective diameter of the circular outline. So if you take lens, right, it will be circular, right? But I mean, there will be some curved part also. That is why they use the word effective diameter. Okay. So the effective diameter of the circular outline of the spherical lens is called as aperture. Now, when the aperture is very much small or very much less, then its radius of curvature, and the two center of curvature are equidistant from the optical center, such lenses are called as thin lenses. And in our syllabus, we have only thin lenses with small apertures. Okay. Next, how do we get principal focus? Last time class already I have told you, we take rays, all the rays parallel to the principal axis. So in the case of a convex lens, it is going to converge at one point. When the rays are coming parallel to the principal axis, they are going to converge, okay, at one point on the right side. So it will converge at focus basically, okay. It will converge at focus. So principal focus of a convex lens is a point on the principal axis to which light rays parallel to the principal axis converge after refraction through the lens or after passing through the lens. It will refract basically and then converge at one point. Okay. Now, because convex lens is converging the rays of light, it is called as a converging lens. Convex lens is called a converging lens because it is converging the rays of light. Okay. And please show the arrows here. So rays of light are coming and here also it is converging. Okay. What is focal length? The distance between the optical center. So here we have optical center, not pole. Pole comes only in mirror. So the distance between the optical center and focus, that is called as focal length. Okay. So a convex lens is also called a converging lens because it converges a parallel beam of light passing through it. It has a real focus. See, real rays are meeting, right? In the case of a convex lens, that is why it is a real focus. Okay, it has a real focus. Now, I told you, we are always going to keep the object left side, right? We are going to keep always object left side, right? So when the rays are coming from left side, it is converging here, correct? So this is focal length. Now, if you see, optical center is the origin here. In the case of lenses, in the case of mirror, pole is the origin. But in the case of lenses, optical center is the origin. So from optical center to right side, it will be positive, right? Because right side from origin to right side is always positive, right? So from optical center to right side, it will be positive. Okay. And left side will be negative. That is why here, because the rays are converging to the right, the focal length is going to be positive. Okay. Next, if you take a concave lens, no, when the rays of light are coming, they will diverge. They will diverge. And they are appearing to diverge from focus, right? They are appearing to diverge from focus, right? That is why we'll actually have put dotted lines here, because they're appearing to diverge from there. See, focus is left side, right? In the case of concave, focus is left side, right? And from optical center to left side is negative, right? That is why concave lens has a negative focal length. Okay. Concave lens has a negative focal length. Okay. Please remember. Okay. So concave lens is also called a diverging lens because it is going to diverge the rays of light. If rays are coming, they will diverge it. Okay. Now, one more thing. While you are drawing the ray diagram for concave lens, first draw the incident ray. This is the point of incidence. You join to focus first. You first join to focus and take your scale and then only extend this. You should draw the diverging rays later on. Please don't draw it initially itself. Otherwise, you'll land up in a trouble. You'll not be able to, you'll get mostly incorrect only. Okay. If you don't do the way I'm telling you, 99% you'll actually make a mistake. Okay. 99% I'm telling you. Okay. So first you draw the incident ray. You join this point to focus and then only extend. Same way. Incident ray, point of incidence, join it, then only extend. Okay. Please remember. Now we have some rules, just like mirrors. In lenses also, we have some rules for drawing the ray diagrams. First rule is, when a ray of light is parallel to the principal axis, after refraction, it will pass through focus. In the case of concave lens, no, it will appear to diverge from focus. See, it is appearing to diverge from focus, right? Yes. Rule 2, when a ray is passing through focus, it is going to become parallel. And here we are directing towards focus, it is going to become parallel. Okay. Rule 3, when a ray of light is passing through optical center, it will go undeviated, okay? They will not ask the reason. There is actually a reason for this. The reason is actually based on the glass slab experiment which we have done, okay? The reason is based on that only, okay? So because the lenses are very thin, right? You can, if they ask, no, you can say because lenses are thin, that is why it is happening, okay? Because lenses are very thin, right? That is actually why it is happening. The lateral displacement here is very negligible. Because lenses are very thin, the lateral displacement here is negligible. And that is why when a ray of light is passing through optical center, it will go undeviated. I repeat, because the lenses are very thin, so lateral displacement will be minimum. And as a result, it will pass undeviated. It will go in a straight line. Okay. So a ray of light passing through the optical center of a lens will emerge without any deviation. Okay. I see people still joining in. In spite of repeating, it feels so bad that in spite of repeating, many of the students are actually joining late. Okay, today I have not enabled waiting room because I don't want other students who actually have joined already and like maybe because of internet issues, if they leave, they will not be able to rejoin. So for that reason, I have not enabled waiting room today, but that does not mean that you can join anytime. Okay, if you're not disciplined, I've already told you, if you are not disciplined, right, wherever you study, it will not help. Wherever you study, okay, you need to have discipline. Okay, without discipline, you will never ever be successful. Please remember that. Okay. Fine. So using these three rules, right? Any two rules we can use. Mostly, in our ray diagrams, we'll be using this rule and the third rule. Mostly. Okay. Using these two rules, we'll be drawing the ray diagrams because we know, right? Wherever the two rays meet after refraction, there only you'll get the image, right? So only these two rules, with these two rules, we can draw the image. Okay. So first of all, you should draw the lens. I had already told you how to draw the lens. Okay, after drawing the lens, you mark from here 2 centimeter, another 2 centimeter. All those things I already told you, right? Yes. So now let's see the first case of image formation by a convex lens. See, if you remember the ray diagram of concave mirror, similar things we have in convex lens also. Okay. Obviously, in concave mirror, the virtual image is right side. Here it is left side. But the properties now are almost the same. Okay. So if you remember the ray diagrams of mirrors, concave mirror, the characteristics is similar to convex lens. And if you see the characteristics of images formed by convex mirror, it is similar to concave lens. Okay, when you do the comparative study, you will understand. Okay, so better learn the mirrors first, and then you can come back to the lenses part. So image formed by a convex lens when object is placed between the optical center and focus. This is optical center, this is focus. Okay, so first, how will you proceed? Maybe I'll actually do this part right now. Okay, you just understand. One diagram only alone I'll teach you. Okay. So you can just, don't do it right now, just listen, okay? First of all, now it's better that you can actually, first of all, take your compass and choose radius as 3 or 4 and draw one arc. Okay, draw an arc. Then go to the other side, okay, and cut this arc in such a way that you get a very thin lens, okay? You should not actually make it very thick. You should not make it thick. That is why if you choose greater radius, no, you'll get thin lenses, okay? If radius you take more, no, lenses will become thin, okay? So you get thin lenses, okay? After that, draw a straight line. You mark the optical center. From optical center, you mark 2 centimeter, you'll get F1. Another 2 centimeter, you mark 2F1. Same way, F2. From here, 2 centimeter, F2. Another 2 centimeter, 2F2. Okay? Now, we are going to place the object between the optical center and focus. So draw 1.5 centimeter line. Okay? Draw 1.5 centimeter line. Don't mark the arrow right now. Don't mark the arrow right now. But you definitely have to put this arrow at the end. Okay? So put this line 1.5. This is the object for us. Okay. Object will have a head and a tail, right? Head will represent by arrow, but now we will not put. We'll put later on. So now you also put dotted line here. I already told you. Okay. A ray of light which is coming parallel after refraction. You please put this arrow mandatory. It will pass through focus. Use your scale. Don't use freehand. Okay. It is going to pass like this. Okay. Now, next, when a ray of light is passing through optical center, it will pass undeviated. So, a ray which is passing like this, it will pass undeviated like this. See, both the rays are diverging, right? So, diverging rays will never meet in that same direction. So, but if you go back, okay, opposite, they will actually meet. How do you actually like draw? How do you make them meet? You take your scale, put your scale on this line, and extend it backward. You cannot do just like that. You have to put your scale and then only do it. Okay. Put your scale on this line and then extend it backward. See, here I'm not getting properly because I'm not using scale and pencil, so it's difficult for me. Okay. So wherever they meet, right? Wherever they meet, there only will get the image. And whenever we have a virtual image has to be represented by dotted lines only. Okay, dotted lines only. So now you put an arrow here. AB is the object and A dash, B dash is the image. Okay. If you look into this particular situation, I told you optical center is going to be the origin, and from optical center towards left side is going to be negative. And we know that the distance of the object, this is the object, the distance of the object from the optical center, that is going to be what? Object distance. So U. So U is negative here because it's left side, and U is always negative basically. And image is here. So distance of the image from the optical center, that is image distance. That is also negative here because it is left side. So both object distance as well as image distance, both are negative here. But it's not always the case actually. But in concave lens, no. In concave lens, image distance is also always negative. In the case of a concave lens, image will be always from left side. So image distance will always be negative. Please remember that. Okay. So in the case of lenses, virtual erect images are going to be formed only on left side. Okay. Please remember that. Okay. So here we have drawn the image, right? So the image is found on the same side of the lens as the object. It's virtual erect and it is enlarged. Okay. Next, we have done the other cases here. Case 2, when the object is at the focus. Okay. So you take the two rays, one parallel, it'll pass through focus, another through optical center, and you can actually, they will actually, so now here, you don't have to make them go backward. See here, the rays are parallel. See, whenever the rays are parallel, they will never ever meet, right? But we assume that they will meet at infinity. They will meet at infinity, just like this one, railway tracks. Okay. So image is formed at infinity. It is highly large. It is really inverted. Okay. Next, when the object is between the F1 and 2F1, you can draw the ray diagram. You'll get to know that it is the image is actually formed beyond 2F2. It is enlarged. It is real inverted. Okay. Next, when the object is at 2F1, please remember this is the only condition in the case of a convex lens where we get same size image as that of the object. Here, you have to remember this particular case. They have asked questions based on this case. In this particular case, the image size is same as the object size. Okay. And image is formed at 2F2. When the object is at 2F1, image is formed at 2F2. It is real inverted image. Okay. Next, when the object is beyond 2F1, image is formed between F2 and 2F2. Okay. Now we know what is object distance, what is image distance, what is focal length. So in the case of lenses, all the three are related by the lens formula. So lens formula is 1 by F is equal to 1 by V. Please remember 1 by V comes first. Okay. 1 by V comes first and then only 1 by U. So 1 by V minus 1 by U. So 1 by F is equal to 1 by V minus 1 by U. Okay. So object distance is the distance of the object from the optical center. See, here they have drawn, right? You please draw it fully, okay, like this. Okay. Whenever you are drawing ray diagrams, please do it. All these things you please follow. Okay. So object distance, image distance, focal length. Here focal length is positive. For a convex lens, no. Focal length is positive. For concave, it is negative because it is left side. Okay. In concave, focus is left side, right? That is why it is negative. Next, infinity. See, in our textbook, they have not given the object, but you can draw the object for infinity like this. And whenever the rays are coming from infinity, we have to put dotted lines, right? Yes. And then rays are coming, they're converging here. So image is formed at focus. It is highly diminished or point size. It is real inverted. Okay. Next is image formation in case of concave. So in concave, only two cases are there. When the object is at infinity, so the rays are going to diverge. They're going to meet here. So the image is going to be highly diminished. It is point size. It's virtual erect at focus F1. Okay. Next, when the object is anywhere between the optical center and infinity, image is going to be formed between optical center and focus. In the case of a convex mirror, when the object is kept anywhere between pole and infinity, anywhere in the case of a convex mirror, when the object is kept anywhere between the pole and infinity, where do we get the image? Put in the chat box. Where do we get the image? In the case of a convex mirror, when we keep the object anywhere between pole and infinity, where do we get the image? Put in the chat box. All of you put, I'll get some water and come. All of you put the answer. Okay. See, the answer is no, Dhalan, it is not right. I asked for a mirror. So the answer is between the pole and the focus. Between the pole and the focus only we'll get. And that you also have to mention behind the, we have to actually mention behind the mirror. Okay. Please mention that behind the mirror. Okay.
Sir, I have a doubt, sir.
Tell me.
Sir, they have drawn arrows for principal axis also, sir, in this diagram. Do we also have to do that?
Yes, actually what is happening now? See, rays of light can come from any part of the object, right? So if you take this object, this is like the toe, right? Like for example, I am standing here. This is the head, this is the toe. So light rays can come from here also, right? So yes, we can draw. Like for this also, we can. It's optional, but if you want, you can do it. Okay. Two rays are enough, right? If you want, you can draw this also. Like rays are coming from the toe, and it is going under. It is going in a straight line because it is passing through optical center, right? So it will go in a straight line.
Okay,
Is
sir.
that clear?
Yes, sir. Yes, sir.
One more thing, everyone. See, anyway, it's revision session. So generally, I mean, like you may not get that much chance to ask doubts, but generally in a group class, when I'm taking live classes, I request everybody to ask doubts. Okay. So all of you, please, like, I mean, wherever you go, wherever you study, feel free to ask doubts. Okay. Feel free to ask doubts. Whatever you have, you should be like freely willing to ask that. Okay. Don't have doubts in mind. Otherwise, what will happen is you'll not be able to understand the concepts. Okay. And there's no, if you're not, if you're having a lot of doubts, then there is no point in attending the classes. Okay. So yeah, let's move forward. So if you look here, when the object here, so I asked the question, where is the image formed? When the object is kept between the pole and infinity in the case of a convex mirror. So in the case of a convex mirror, no, the image will be formed between pole and focus and behind the mirror. Okay. It's like this. We are having a convex lens. Sorry, convex mirror. Okay. Focus will lie somewhere here. Center of curvature will be somewhere here. This is pole. And I'm keeping anywhere, right? Between pole and infinity. Suppose I'm keeping it here. Okay. So rays of light will come. Dotted line I'm putting. And see, first of all, you have to join, then only you have to take it backward. Please remember this, okay? And when a ray is passing through. So now what do you do? Now take your scale and join these 2 points and then you like draw the line. Okay. So when the ray is coming like this, it will retrace, come back like this. Okay. So both are intersecting here, right? So image will be formed here. Dotted line, okay? It has to be dotted line. So A, B, and A dash B dash. So you see image is formed between pole and focus behind the mirror. So you have to mention like that. So same way, in the case of a concave lens, no? Because the rays are diverging here, image will be formed here. It will be formed left side only. So in the case of lenses, no, virtual image will be formed left side. And real image will be formed right side. But in the case of mirror, real image left side, virtual image right side. So it's quite opposite. So you have to practice ray diagrams, okay? So image is actually formed between the optical center and focus. It's actually virtual erect, it is diminished. So just like convex mirror always forms virtual erect and diminished image, same way, concave lens always forms virtual, erect, and diminished image, always. You please remember this, okay? Okay. Next, moving forward. So here I have drawn the ray diagram for that. Okay. Next, we have the lens formula, which relates the focal length, image distance, and object distance. Okay. Next, we have the concept of magnification. See, whatever concept I explained in the case of mirror, the same is applicable here also. Okay. I'm not going to repeat all those things. You just learn the formula. Just remember, here we have a plus. We don't have a minus here. Okay. Whenever plus is there, we don't put actually. Okay. So same way, like I told you, right? HO is always positive. HI, if it is positive, that means it is virtually erect. And if it is negative, it is real inverted. HI is what? Height of the image. So virtually erect means it will be above. Real inverted means it will be down. That is why it is negative. Okay. Below the principal axis negative, right? That is why it is negative. So whenever M is negative, it is real inverted image. Whenever M is positive, it is virtually erect image. Remember that. Okay. And based on the value, if the value is more than 1, that means height of the image is more than height of the object. If the value is less than 1, height of the image is less than height of the object. And if M is equal to 1, both are same. So magnification will have two things. One is sign, another is magnitude. Magnitude is value. Okay. Okay. So next, this is a word problem like numerical. It says a 2 centimeter tall object. So 2 centimeter tall object. So there is actually an object. The height of the object is 2 centimeter. Okay. So a 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens. Now see, if somebody has asked some doubts, please don't be actually thinking about that. First, you listen to this. If you have asked doubts, you please wait. Okay. Because sometimes you have to just wait to be able to understand. Okay. So please focus on this right now, everyone. Okay. Because next, I'm going to give one question. You have to do it and tell me the answer. Okay. So it says a 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. Okay. See, whenever you're using the lens formula or the mirror formula, you have to use this along with the new Cartesian sign convention. That means whenever you're substituting values, you have to substitute along with the sign. Okay. So look here, we have height of the object is 2 centimeter and object height is always positive because it is placed above the principal axis every time. Okay. Focal length is positive and U is negative because object distance is always left side, right? Object is always kept left side, so U will always be negative. Focal length is positive because convex lens will actually converge the light rays on the right side. Okay. So given data understood, then to find out, we have to find image distance, we have to find height of the image, and we have to find the nature. So use the lens formula, like put the values, simplify. This is actually fully mathematics. You will actually get V as 30. After you get the answer, now you have to write one conclusion. Many of you are not writing conclusion. If you don't write, you lose marks for sure. Okay. So write the conclusion. The image is formed at a distance of 30 centimeters on the right side of the lens. You mentioned right side, left side, you mentioned that. Okay. Next, magnification. Using magnification formula, we can find height of the image. That is 4. See, -4 is coming. See, -4 means image is down. -4 means image is below the principal axis. So when you say write the conclusion, don't write -4. You say size of the image is 4. Why it is coming minus? Because image is real. That is why it is down. And that is why it is minus. Okay. So here in this magnification formula, we know HO, we know V because we have found out V. We know U. You put the values, you'll get the answer. Simplify, you'll get the answer. Okay. Magnification also they have asked. We have found magnification by using the formula. We have got -2. And after that, we write the conclusion. Image is real, inverted, and magnified. Okay. If you look here, image is 4, object is 2. So image is magnified, right? It is real inverted because it is down, right? And then draw the ray diagram for this case. This question I gave additionally. Draw the ray diagram for this case. This one I gave additionally, right? So how to draw ray diagram for any case? I told you, you always require U and F, always. So U is given 15, -15, and F is 10. So first draw the lens. From optical center measure 2. And here again another 2. Okay, right side 2, 2. Okay. After that, although this is 2, but it is corresponding to 10. So if this is 10, this will also be 10. Okay. So if this is 10, so generally in the case of lenses, focal length we mark on the, like for convex lens, focus will mark on the right side because rays are going to converge here, right? If this is 10, this will also be 10. Same way, if this is 10, this will also be 10. Correct? So 10, 10, 20. Where is the object 15? So it is less than 20, right? So 15 will lie where? This is 10. Half of 10 is 5. So exactly here it will lie. Exactly middle point here. Okay. This is how you locate the object. And once you locate the object, you can easily proceed. But this location is very, very important. You cannot put anywhere. Okay. This is 10, this is another 10, 20. 15 is less than 20. So this is 10, half of 10 is 5. So 10 plus 5, 15, you'll get it here. So simple. Okay. So I hope you are able to understand. It's actually very, very simple. Okay. Next, I have done a few more questions here. Next, with respect to concave lens, I have done questions. You can see a concave lens of focal length 15. At what distance should the object from the lens be placed so that it forms an image? So here they have given object, like here they are asking object distance. Here they are not given that. Here they're asking where will you place the object so that the image is formed at 10 centimeter from the lens. Now, if you don't know that in the case of a convex lens, image is from left side, you cannot proceed with this question. Okay. So also find the magnification produced by the lens. So focal length is negative for a concave lens. And image distance is also negative. That is why V is minus 10. Here they have given image distance, right? It forms an image 10 centimeter from the lens. That is image distance. That is minus 10. So you can actually use the lens formula and find the U value. Okay, just substitution and simplification, you'll get the answer. So once you have got the answer right, write the conclusion. The object should be placed at a distance of 30 centimeter on the left side of the lens. Left side, right side. Okay. Don't write in front and all. Don't write in front. You write left side, right side. You write like that. Okay. And use magnification formula, find magnification. Okay. Next, draw. Okay, see, they have asked this question for 2 marks. This is actually from the board. For 2 marks, they had asked this. Draw a label diagram for the formation of image by a convex lens of focal length 15 when the object is placed at a distance of 25 centimeter from the lens. So draw the lens first. After drawing the lens, mark that 2 centimeter, 2 centimeter. So this is actually 15. This is also 15, right? Because focal length is 15, right? So 15 plus 15, 30. Up to here, it's 30. Okay. Up to here, it's 30. But where is the object? 25. So 25 is less than 30, right? Now, half of 15 is 7.5. So up to here, it will be 25, 22.5. So 25 will lie somewhere left. I'll put it here. Same thing I had explained last class also, but it was with mirror. If you remember, we had a similar question with mirror. Okay. So from here to here, it's 15. From here to here also 15. Half of 15 is 7.5. So up to here, it will be 22.5. So 25 will lie to the left side of this over here. Okay. And once you put the object, so object here is between the F1 and 2F1. So image will be formed beyond 2F2. That is what we have drawn. Okay. Look here, I have drawn it. Okay. Next, power of a lens. Just 1 minute. Okay, so next is power of a lens. See, power of a lens means the ability of a lens to converge or diverge. See, convex lens will converge and concave lens will diverge, right? We know, right? Concave lens will converge the rays of light. Concave lens will diverge. Convex will converge. Concave will diverge. So, power means ability. Power of a lens is the ability of a lens to converge if it is a converging lens or to diverge if it is a diverging lens. So power of a lens is the ability of a lens to converge or diverge the rays of light. But you should not write this definition in the exam. If they ask what is power of a lens, we do not write this definition. That is why I have given in the third line. You have to write like this. Power of a lens is defined as reciprocal of focal length in meters. Focal length has to be in meters. Please remember, 90% of the people make mistakes while calculating the power of a lens. Okay. So power of a lens is defined as the reciprocal of focal length in meters. Okay. So power is equal to 1 by f. Reciprocal of focal length is 1 by f, right? Now focal length has to be in meter. When focal length is in meter, power comes in diopter. So power has got a unit. Like for example, length we measure in meters, right? Meter, centimeter, kilometer. But standard is meter, right? Same way for power, the unit, the SI unit, the standard international unit is diopter. Okay, represented by capital D. Next, we know power of a convex lens is positive. Why? Because focal length is positive. If F is positive, this will also be positive only, right? See, P is equal to 1 by F. If this is positive, this will also be positive only, right? Because 1 is always positive. This is number 1. So positive by positive is positive. So if focal length is positive, power is going to be positive. If focal length is negative, power is also negative. So simple. Okay. The SI unit of power is diopter. It is represented by capital letter D. If F is expressed in meters, then power is expressed in diopters. One diopter is defined. So sometimes they'll ask what is a one diopter. So how will we get one diopter? When focal length is 1 meter only, we'll get, right? See, when focal length is 1 meter, 1 by 1 will be 1 diopter. So 1 diopter is the power of a lens whose focal length is what? 1 meter. Okay. Okay. Is it like that? No, you please don't write like that. Okay. So here actually one of the students actually he has messaged that his teacher actually, I don't know how some teachers are telling it like that. He has messaged me that when I wrote in my pre-board, my teacher told me to write the definition given in third line. You have to write power of a lens is reciprocal of focal length only. If you check the answer key, that will only be given. So you please don't write that third line one. Don't write ability to converge or diverge. You should not write that. Okay, please remember. And one of the students yesterday, she messaged me that the teacher is asking to draw the ray diagram in pen, no pencil. Please don't do like that. No, pen is not allowed. You ask anybody, we cannot draw ray diagram in pen or any diagram for that matter. No pen. Even labeling also use pencil only. Okay. Please, everyone. Okay. Okay. So now let me come back to this one. Okay, so you have understood this power. I have explained the concept of power through some examples. Okay. Now suppose we are having number of lenses. Okay. Where we are having number of lenses which are combined. So how we can find the power of combination of lenses? By taking the algebraic sum. Okay. So power of number of lenses is going to be the power of the algebraic sum of the individual lenses. Okay. But one more thing, when you are actually adding the powers of the individual lenses, you have to take along with sign. That is extremely important. I repeat, suppose I have given 5 lenses. I have been given 5 lenses. Okay. So power will be P1 plus P2 plus P3 plus P4 plus P5. See, in that, suppose 2 are convex and 3 are concave. So concave focal and power will be negative, right? So you have to put negative value. They will not give in the question. They will not say it is negative. You have to take a negative. Suppose they say, I'm having like convex lens. I'm having 2 convex lens of power 10 and 20. And having 3 convex lens, concave lens. I'm having 3 concave lens of power maybe 20, 30, and 40. For example, so while putting here, you put 10 and 20 positive because convex. For concave, now you have to put minus 20, minus 30, and minus 40. Okay, because plus into minus is minus, right? That is why directly I'll put minus. And then simplify, get the answer. Okay. So here I've given one example. Look here. Suppose I have got 2 lenses. One is having a power of 4, another is having a power of actually minus 10. They will not give, you have to take it minus 10. Okay. Concave is minus. See, if you combine both of them, what will be the total power? Total power will be the algebraic sum, right? So 4 minus 10 is minus 6. That means what? When you combine these 2 lenses, no. When you combine one convex lens of power 4D and a concave lens of power 10D, it will behave like a concave lens of power 6D. I repeat. I am taking a convex lens of power 4D and a concave lens of power 10D. When you combine the total power, I'm getting minus 6D, right? Minus means what? Concave. That means this combination will behave like a concave lens with a power of 6 diopter. Okay. So all those things I have explained here. Okay. Next, this question is extremely important. It says a convex lens forms a real and inverted image of a candle at a distance of 50 centimeters from it. I repeat, a convex lens forms a real and inverted image of a candle at a distance of 50 centimeters from it. Where is the needle placed in the front of a convex lens if the image is equal to the size of the object? Okay. See, we know the only case where we get the image size same as the object size is when you keep the object at 2f1, right? Then only you'll get the image as 2f2. Yes. Now they've given image distance here. Image is found at a distance of 50. That means object will also be at a distance of 50 from the lens. Okay. So you know this is object distance, this is image distance. This is positive, this is negative. You use the first of all, you use the lens formula to find focal length, and then you can find the power. That is what actually I have done here. You can look here. See, you actually find we have U and V. We can actually find the focal length I have done here. Okay. Focal length is 25, but this is centimeter. So convert to meter by dividing by 100 and then find the power. Power is 4 diopter. Please convert centimeter to meter to be able to find the to be able to find the power in diopter. You have to convert centimeter to meter for sure. Okay. Please remember that. Okay. 1 minute. Some people have asked some questions. Just 1 minute. I'll discuss that. Okay. But before that, just one more question. You can see same thing. Okay. Converging lens is there. I write the given data and draw the diagram. Okay. So I'll take up the questions also, and then I'll discuss this. Okay. This one I'll discuss after I give some questions. Just let me take up some questions right now. 1 minute. One of the cases of convex. Yes, Harshit, I will take it. Yes. Yes, because focus is the point where the rays are going to converge after when the rays are parallel, right? So you have to take convex as positive always. Okay. Yes. Okay. Yes, sir. If one diopter defines one. See, Sri Shubhavashani, actually, it's not like that. We don't have to actually specify -1D for concave and all. Generally, see, for concave and convex, we write the sign. Okay, but generally, if they ask power, no, we'll just define it as having power of a lens is 1 diopter when focal length is 1 meter. See, we know power is equal to 1f. Okay, so if they ask 1 diopter, see, obviously we know that for convex, power is going to be positive. For concave, it is going to be negative. We know that. But if they ask, no, we don't have to mention specifically that it is for convex or concave. We can generally write. Okay, we don't have to be very specific about that. We can just say when the focal length of a lens is 1 meter, then power is 1 diopter. And if you want to be very specific, you can mention that this it is 1D for convex and -1D for concave. Like that you can mention. Okay. In lens, V cannot be negative. See, in the case of lenses also, right? V can be negative, right? I mean, if you're getting an image on the left side, for example, virtual image, it is negative, right? It is possible. Mahania, don't write like that, 100 by F. I mean, first of all, you write 1 by F and then you put the values accordingly and you go ahead. Okay. Can we draw this? Can we draw the electron dot structure? Electron dot structure, you don't draw with pen. Structural isomers, maybe you can write, but don't do actually electron dot structure. Okay. Swayam, what did your teacher advise? School teacher.
Pencil, sir.
Pencil only, right?
Yes, sir.
What about structural isomers?
Both are pencils.
Both are pencils. Okay. Okay. So all of you, please, try to draw all the diagrams with pencils. So Swayam is actually from KV, Kendriya Vidyalaya. So in Kendriya Vidyalaya, we know we have highly experienced teachers. Although like in some of the Kendriya Vidyalaya, we don't have actually good quality of teaching. But yes, in most of the Kendriya Vidyalaya, we have very good experienced teachers. So like if they are saying in pencil, we have to do only in pencil. And see, by looking at the answer key also, I have actually seen that they're expecting us to draw diagram only in pencil. So please everyone follow only in pencil. Okay. Draw the diagram only in pencil. Okay. So I'll give some questions now. Just 1 minute. This question I gave last class also. Now also I'll give again. Try everyone. Quickly tell me the answer in chat. Adira, can you check once? All of you are right. Shyam, check once. All of you are right. Other people, Adira, correct. Everybody else right. Good. Very, very nice. All of you are right. See, the answer is option C. Okay. The answer is option C. How? It says, at what distance from a convex lens should an object be placed to get an image of the same size as that of the object on the screen? So only if you have the object at twice the focal length of the lens, then only you'll get right. Yes or no? Beyond, if you take, you'll not get same size. Okay. Beyond, if you take right, you will not get. Okay. I'll give one more question. Yesterday, somebody had actually asked me. Okay. I'll just give you one. Just give me one. Yesterday, somebody had actually asked me on WhatsApp. Okay. Okay. All of you, please try out this question. Tell me the answer in the chat. Yes, Pranav, we'll do refractive index also. Just we'll do some questions based on this and then we'll start with the refractive index also. Don't worry. All of you try this question. Mahania not correct. Nikhilesh, you are right. Very nice. Swayam right. Very nice. Pratik not right. Lakshana right. Arush not right. Advik not right. Adira not right. Harshita not right. Kamlesh right. Sarvesh right. Pranya right. Badra right. Mrityunjay right. Likhit right. Niharika right. Shyam right. Varsha Ramanathan right. Pritika not right. Sriram Balaji not right. So all of you just think for a moment. I'll give you some more time and I will discuss after this. First you try everybody. Okay, let's understand all of you. Please, all of you just listen, okay? It says the image of a candle is formed by a lens is obtained on a screen. On the other side of the lens. See, in the case of a lens, if image is from right side, it will be a real image. Left side only virtual image. And only real image we can get on the screen, right? So it has to be a real image. Correct? Now, whenever image is real, magnification will be negative. See, M is what? What is M? HI by HO? HO is always positive, right? HO is always positive because it is above the principal axis. What about HI? If it is a real image, it will be negative because it will be below the principal axis. So negative by positive is negative. That means if you want a real image, M has to be negative. So these two options are ruled out first. These two options are ruled out. Yes. Now concave lens can never form real image. It's always virtual erect and diminished image. So answer is convex. Option C. If anybody is having a doubt, please ask. So simple. I hope you have understood. It is a convex lens, not concave. Because if it is concave, we cannot get a real image. It will always be virtual, erect, and diminished image. Okay. I hope you're all getting. Please, everyone, revise. Okay. I have already explained all the concepts in detail during the regular classes. This is just a division to help you. Okay. But please do a lot of self-study. Okay. Wherever you learn, it's always going to be self-study, which is going to play a very important role. Okay. 90% is your effort. Only 10% is my effort. 10%, that's all. Okay. So please take care. Okay. Next question. Feels so bad. Even see, Rayan, even yesterday you were actually late. It feels so bad. Actually, see, this guy actually, and see what happens. I have seen from my personal experience actually for so many years. Those guys who are coming late now, they will always be late, and they will give some excuse. That internet issue, this issue, that issue. They will actually come up with some issue. Okay, and that is just an excuse they are giving. Okay. Now, there are some people who are very genuine also. That is also there. I mean, really, there may be a trouble, but you have to look to rectify that issue. You have to look to rectify. Okay. Always, if you give some excuse that, like, see, generally during the regular classes, no, I ask everyone to switch on the videos. Okay. Now, since it is revision, okay, I thought, okay, it's okay. Let's not force everyone to switch on the video. It's okay. In that also, there's many people will give excuse. They will say camera not working or this not working. I mean, no, internet is very slow. They will give all those excuses. Okay. Please never ever give any excuses, everyone. It's only for you. Your parents have organized. They're actually looking for teachers just for you only. Okay. And if you're not using it properly, you're just doing injustice. Okay. Even yesterday, this guy actually, again, he had joined late yesterday. So I have seen like many people, like, I mean, the same thing, they will actually keep doing it. There's no point also. Actually. Okay. So we'll try this question. All of you just read and write the answer in notebook. I'll just give you the other questions also in this. It has got two parts. Just write the answer in a notebook. No chat. Don't write in chat, okay? Just write in a notebook and then we'll discuss, okay? Maybe this one I'll try to put it. Okay. Okay. Try. All of you just write in a notebook the way you will write in the board exam. And then I will discuss, then you can check.
Excuse me, sir.
Yeah, please tell me.
Sir, in the last line it's given as microscope forms virtual, inverted, and magnified. How can virtual image be inverted, sir?
Okay. In our laboratories, we use a compound microscope to select a See, you forget about, actually, I mean, like, yeah, there may be some mistake, but you just forget about this theory part. Anyway, this theory is not required to solve this question also, okay? So you just ignore that, okay? You just ignore that, okay? Here they have given correctly the eyepiece forms the resultant image from. You ignore that, okay? Just try this question. You ignore that part. These parts are not even required. See, they just give, see, case-based means just, they'll give some theory which is already not even required to solve the questions. Most of the time will not be required. Just try this question. We can solve without that also. Okay. Okay, here it says the resultant image, no? Resultant image formed with respect to. So that is actually possible, okay? See, anyway, we have not seen compound microscope, the functioning of that. So that is why you will not be able to understand. Okay. So like, there may be some concepts associated with result like compound microscope that is possible. Okay. Because they are like measuring with respect to microscopic object viewed. So something may be possible. You just ignore this. It's not required to solve the question, but okay. Okay. So let's discuss everyone. Okay. See, this part, I mean, is not even required, okay, to solve this question. They're just given some theory here. Let's come back to the question first. It says the image of an object formed by a convex lens of focal length 2 centimeters is real, inverted, magnified. What is the range of object distance in this case? So they are taking a convex lens, okay? They are taking a convex lens, okay? Optical center. This is F1, 2F1, okay? F2 and 2F2. Okay. Now, what is the focal length 2? So from here to here, it's 2. So here also it will be 2. Here also it will be 2. Yes. Here also it will be 2. Okay. That means up to 2F1, it is 4. 2 plus 2, 4. Correct? 2 plus 2, 4. Now, we know that if you want to get a real inverted image, we can keep at F1. We can keep here, 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 infinity, but we cannot keep in between. If you keep in between, you'll get virtual erect. So if you want to get an image, okay, if you want to get a real inverted and magnified image, the range of distance has to be greater than, you can actually say, it's given more than 2, okay? You can say greater than, okay, you want magnified also, right? Just 1 minute. Just 1 minute. See here, we want real inverted and magnified image also. That is also important. Real inverted and magnified, okay? See, we'll get real inverted magnified image at F1. When you place the object at focus, we'll get real inverted and magnified. This is possible. If you keep here, if you keep between F1 and 2F1, then also we'll get real inverted magnified. It will be found beyond 2F2. Yes, that is also real inverted magnified. Now, if you keep here, same size you'll get, right? Same size. If you keep at 2F1, you'll get same size. If you keep beyond 2F1, you'll get diminished. So range has to be like 2 or more than 2, but less than 4. Not at 4. Please, I repeat, if you keep at 2, you will get magnified image. It is actually highly magnified, basically. It is highly magnified. Okay. So at 2, we'll get highly magnified. Here, they just told magnified. So, like maybe we can say 2 also, not a problem. But in the answer key, they have told more than 2 and less than 4. Why less than 4? Because if you keep at 4, you'll get same size. So 4 is not possible. 2 is actually possible, but in 2, now we get highly magnified. But here they have mentioned just magnified, not highly magnified. Here they have told magnified. So we can say the answer is, for this particular case, range of object distance is more than 2, and less than 4. So you can say between 2 and 4. Between 2 centimeter, you mentioned the unit also 2 centimeter. It's centimeter and 4 centimeter. Okay. I hope you have understood. Okay. Between 2 centimeter and 4 centimeter from the optical center. Actually, in the answer key, they have also given from the optical center. See, we are measuring everything from optical center only, right? So between 2 and 4 from optical center. So like it has to be greater than 2 and less than 4. Then only you will get magnified image. Okay. I hope you have understood. Just check once. If anybody is having a doubt, you ask. Okay. It's not 0 to 4. Adira, have you understood?
Yes, sir.
Okay. Okay. And actually, some people know they're actually always giving this kind of thing. I mean, we can write this for sure. Okay. Greater than 2, less than 4. Okay. We can write like this also. This is also fine. It's allowed. But I mean, you try stick with this itself. I'll show you the answer key also how they've given. They've given more than 2, less than 4 from the optical center. So this is how they have given. I've given you the explanation why it is more than 2 and less than 4. Okay. Next question. They have asked, the image of an object formed by a convex lens of focal length 6 is virtual, erect, and magnified. Focal length is 6, we are getting virtual, erect. What is the range of distance in this case? See, if you want virtual, erect, and magnified image, we keep between optical center and focus, right? Correct? So optical center is the origin and focus is the focal length. So between 0, you have to mention between 0 to 6. Okay, between 0 and 6, not 2, between 0 and 6. Okay, between those two values. Okay, so actually they have told less than 6, but anyway, between 0 and 6 means that only. Okay, here the answer key says less than 6 from the optical center from the lens. Okay, see, less than 6 means 0 also, like people will take. That is why it's better you write between. Okay, see, less than 6 means what? Negative also is included, right? Okay, so it's better. I mean, but actually here they have told optical center, so that is why it's fine. But you please mention between 0 and 6. That is much better. You can mention between 0 and 6. That is much better. Okay. Okay, here anyway, optical center is given. Okay, even this is fine. Just 1 minute, everyone. Just 1 minute. See here, optical center is origin. Less than 6 from the origin means it is between 0 and 6 only. So here, this also is correct only. We can write like this also. Okay. Either you write this or you say between 0 and 6 centimeter. Okay. Like that you can write. Okay. Next. It says an object is placed at a distance of 12 centimeter from the optical center of a convex lens of focal length 18 centimeter. Draw the ray diagram to show the image formation in this case. What do we do? First, you draw the lens. Draw the line, mark the optical center, mark the F1, mark the 2F1, mark F2, mark 2F2. Okay, what is focal length? 18. So here to here it's 18. Here to here also 18. So again 18, totally 36. Where is the object? 12. 12 means in between this one, these two. So 12 will be somewhere here. Not actually, see, half of 18 is 9. So 12 will lie somewhere here. Okay. So here you put the object and complete the ray diagram. Okay. So the ray diagram is given here. It's this one. Okay. The object is, see, they have also kept little left side, right? Middle is this one, left side they have kept, right? So please be careful while choosing the object, where the object is. Okay. Next question. It says the image formed by a convex lens is real, inverted, and of the same size as that of the object. Okay. Maybe I'll take this question to the next page. Okay. So if the distance between the object and the image is 60, that means they have given like, okay, the distance between object and image is 60. Determine the focal length of the lens gives justification for your answer. See, I'm having a convex lens. See, we get image size to be same as the object size only when the object is a 2F1. So optical center, F1, 2F1, F2, and 2F2, correct? So only if you keep the object here, you will get same size image here. Distance between the two, that is image and object, that is 60. Okay. This is exactly the middle point, optical center. So this will be 30, this will be 30. That means object distance is 30, image distance is also 30. Okay. So now we know, right? This is F1, this is also F. Both are F. So F plus F, that is 30. So 2F is equal to 30. So what will be F? 15 centimeter. Okay. So the focal length of the lens is 15 centimeter. Okay, I'll show you the answer how they have done it. Okay. So actually, they have drawn the ray diagram first to be able to explain. So only if object is here, image will get here. They have given this distance 60. So half 30, 30, that is, this is 2F. So we can get, so 2F plus, otherwise we can do like this also, 2F plus 2F. This is 2F, right? This is 2F. That is 60. So 4F is 60, F is 15. Focal length is 15. Okay. Diagram is actually optional. Like they have already given, do not deduct marks if diagram is not drawn. Okay. Lens formula. Yes, lens formula also we can use. See, actually, from the like given question, we can say U is 30 and V is also 30. Lens formula also, if you use 1 by F is equal to 1 by V minus 1 by U. 1 by F is equal to, V is what? Positive because right side. So 30 and U is negative minus 30. So 1 by 30 plus 1 by 30, that is 30, 1 plus 1, that is 2 by 30, 2 by 15, 1 by 15, that is 1 by F, F is 15 centimeter. Okay. This way also we can do. Okay. Okay. But still we have to write, we have to say that we get the same size image only when the object is at 2F1. Okay. And since the distance between 2F1 and 2F2 is given as 60, okay, that means 2F plus like that, like, I mean, you have to say that, okay. And then, I mean, you can say that the object distance will actually be 30, so image distance will also be 30. Then only you'll get that 60, right? And then you have to proceed that way. Okay. I hope you have understood. Okay. So now what we'll do is we'll actually move on to with the refractive index. Maybe I'll give one more question and then I'll discuss the refractive index concept. Try this, everyone. All of you try this. Okay, good. Majority of you are right. The answer is option A. Okay. The answer is option A. It says when object is placed beyond 2F of a convex lens. Okay. The nature of the images is going to be, first of all, real, inverted, and diminished. Answer is option A. Okay. Next, let's quickly revise that refractive index also. And then we'll solve some questions based on that also. 1 minute. Can you all try this question as well? Very good, Likith, right? Yes, Nikhilesh, right? Parsha, not right. 1 minute, 1 minute. Ah, yes. Varsha, you're not right. Check. 1 minute. Some more people have, so many people have responded now. Okay. We will discuss. All of you just put the answer, we will discuss. Okay. So Arush not right. Adira not right. Daksha not right. Swayam not right. Mritunjay. See, Mritunjay, why don't you give the option? I mean, you please all give the option. Okay. Don't write the statements. Okay. It's a bit tough. Okay. Vaishnavi not right. Sarvesh right. Adira. We'll discuss anyway. Like, because anyway, I cannot take names of everybody. It's quite tough. Let's understand this, okay? It says a convex mirror always. See, whenever this condition always is given, right? Even if one of them is not correct, no, this will become false. Okay. Always means even if you get only one condition to be wrong, this statement will become false. Always means should be always applicable. Okay. All the conditions. So a convex mirror always forms an image behind it, and the image is formed as virtual. See, if you take a convex mirror, okay, wherever you keep the object, whether it is infinity, then the image is actually going to be formed behind and it will be virtual. Convex mirror always forms virtual image and it is always diminished and it is always behind. So this is true only. According to the sign convention, the focal length of a convex mirror is positive. This is actually true. This is also true. Focal length of a convex mirror is positive, right? Because all the rays will come actually like this. They will diverge and it will, I mean, they are appearing to diverge from here. So it is going to be positive from pole to right side is positive. So both statements are true. Now, when both statements are true, no, 90% of the students have a confusion whether the answer is A or B. Okay. When both statements are true, A or B, which is correct, it's very confusing. So always find out whether this is the, actually already in the question they have told whether this is a correct explanation or not. So you apply because. Is this happening because of this? A convex mirror forms the image behind and the image is inverted. Is it because of this? Not at all. It's not because of this. Okay. It's not because the focal length of a convex mirror is positive. This is actually true, but it is not because of this one. Okay. So that is why answer is option B. If anybody is having a doubt, you please ask.
Sir, can you tell me the actual reason for which A will be the answer?
See, actual reason, maybe, I mean, like something else can come, but here it's actually, have you understood this part first of all? Yes or no?
Yes, sir, understood, sir.
Yes. So actual reason, I mean, that is actually the intrinsic property. I mean, the convex mirror is always forming like that. Okay. Actual reason, what can come there is and the image is formed as virtual. See, it can be, a lot of things can be framed here. Okay. But as of now, let's say actually stick to this question. This is actually answer is option B here. It's not true.
Okay, sir.
This is not the correct explanation. Is that clear?
Yes.
Yes.
Sir,
Okay.
sometimes for me, because it's not working, sir.
Okay. But majority of the time it will work. Majority, sometime only maybe 5% of the cases it will not work, but majority of the cases it will work. Okay. Majority of the cases it will work.
So,
Okay.
what to do for such cases, sir? Like when it does.
Such cases, it's all practice only, I would say. With practice only, you'll get to know about whether it is A or B. With practice, maybe you can just practice some more questions, and then with that, you'll come to know. But in sometimes I have seen that in the answer key also, Most of the places they have given wrong. A or B, whenever
Yes.
there's a or B, right? Most of the places they have given a wrong answer. So we are also not able to, like, students also find it very difficult to judge whether it is A or B. Okay, but here I made it very, very clear why it is B. Okay.
Yes, sir. Thank you, sir.
Yes, yes. Okay. Let's continue. Maybe okay. With this, maybe one last question. All of you, please mute yourself. Try this question. Write the answer in your notebook, not chat. Okay, let's discuss this. It's very easy. It says the above figure shows the formation of an image by a lens shown by thick lines. Okay. So you can see the lens is actually shown by thick lines. See this one. Okay. Analyze the figure and answer the following questions. What is the lens? What is the type of lens used? So, if you want to get a virtual erect image which is magnified, we have to go for convex. Please remember, if you want to have a virtual erect image which is magnified in mirror, we have to choose concave. And we have to place the object between pole and focus. But in lenses, you have to choose convex lens and you have to place the object between optical center and F1. Okay. So answer is convex. This is convex. Okay. Next, what is the nature of the image? It is virtual, erect, and magnified. Okay. See, nature generally deals with virtual, erect, or real inverted, but you write the size also. Because some places, they have given size also. So you write virtual, erect, and magnified. Okay. If the image is formed at a distance of 30 centimeter from the lens, okay. Please don't annotate everyone. Please stop it aside. Okay. So if the image is formed at a distance of 30 centimeter from the lens, so that means they have given image distance, and the image is twice the size of the object. Where is the object placed? Okay. See, they are saying that the image size is twice the object. The image is twice the size of the object. So HI is 2 times HO. From here, HI by HO will be 2. Correct? That means magnification will be 2. Now, magnification has got sign as well as the value. So value is 2. What is the sign? Okay, it says if the image is formed at a distance of 30 centimeter from the lens and the image is... Okay, now here, see, actually, they have not mentioned anything. But since if you look at the diagram here, we'll assume that the case is of this only. Okay. We'll assume the case is of this only. Here, if the image is found at a distance of 30, we'll take this case only. If the image is found at 30, and the image is twice the size of the object, then where is the object placed? See, when the image is virtual erect, the magnification is positive. When image is virtual erect, then the magnification is going to be positive. So M will be positive. Correct or not? Yes, I'm taking this particular case only. But I mean, we can have image size twice the object size when the image is real also. That is also possible. Okay. So if you want, you can show both the cases. But I think so because they have given this diagram and they're asking questions based on this diagram. We have to choose only virtual erect image. Okay. And that is what is given in the answer key also. So M is +2. Now what is M also equal to? HI by HO, which is equal to V by U, correct? So M is 2. Okay. We want to find U, but V is given as 30. And since image is going to be on the left side, it is -30. Because we have to take along with sign, right? And this is U. So what is U? Cross multiply. So -30 by 2. That is -15. That means object is placed at a distance of 30 centimeter from the lens, on the left side of the lens. Okay. So I'll show you how they're given the answer. Yourself, everyone. Look here. So the lens is convex lens, image is virtual. Magnification they have given is 2. Okay, it's actually a +2 because it's a virtual image which they have taken. Okay. But suppose one more thing actually I want to actually say. Suppose this question was given independently. Okay. I'll just take that question itself. See, if this was an independent question, if this was an independent question, then here, no, we'll have two cases. Let me solve it. Okay. See, if the image is formed at a distance of 30 centimeter from the lens, and the image is twice the height. Okay, where is the object? Just 1 minute. Okay, let's calculate. All of you listen. Okay. Let's understand. Sai, can you please stop disturbing? I mean, like you had not joined on time, and I mean, you cannot understand anything. So you please leave the meeting. Okay. If you join just like that anytime, it's not possible to understand. Okay. Yes. Let's understand, everyone. If the question is given independently, let's understand how to solve. See here, if the image is formed at a distance of 30 centimeter from the lens, so V, case 1, okay. When the image is I'll take virtual erect first. Virtual and erect. See, when the image is virtual erect, V will be left side. It will be left side, right? Virtual erect. So if the image is formed at a distance, so it will be -30. Yes, we have to find where is the object placed. So you have to find U. Correct? And they have told that the image is twice the size of the object, right? So magnification we got +2. Why +2? Because it's virtual erect. So M will be V by U. So 2 is equal to V by -30. Cross multiply. Sorry, sir. V is actually -30. U we have to find out. U is equal to -30 by 2. That is -15 centimeter. So write one conclusion. Therefore, the object is placed at a distance of 15 centimeter from the lens. Left side, basically. Case 2. When the image is, okay, when the image is real and inverted. Okay. So in the image, V will actually be positive because image real inverted is on the right side always. Okay. So it will be positive +30. Okay. What about M? M will be -2. Okay. M will be -2. Okay. Why? Because it is a real inverted image. So it will be -2. So M will be equal to V by U. So -2 is equal to, okay, -2 is equal to V is 30 by U. Here also we are getting actually -15 only we are getting. Okay. But how it is possible? Just 1 minute. Here also -15, here also -15. Focal length. See, we know, right? There are two cases actually. In one, see, in this case, no, object will be between the optical center and F1. But here it will not be between optical center and F1. Okay, it will be so that is why we have two. This is a different case altogether. Both are not same. Both are two different things. See here, no, although both the values are same, but actually the situation is different. Here, U is 15 is like here when U is 15, the object is going to lie between optical center and F1. But here when U is 15, the object is going to lie between F1 and 2F1. Both are different cases actually. You understand? I hope you are able to understand. We are going to get magnified image, a real image, when object is between F1 and 2F1, right? Then only you'll get magnified real image beyond 2F2, right? So this is that case. Here, if you take virtual erect, this U is minus 15 means it is between the optical center and F1. Okay. So although both are same, but both mean differently. Okay. I hope you have understood. Okay. But since they have given the diagram, you please take this case alone. In the answer key also, they have taken only one case. That is this one. Okay. Yes. Correct. If you consider the diagram, case 1 will be applicable. So we can just go ahead with that. Okay. Now let's come back to refractive index. It's anyway, we have less time left. So we'll just see the refractive index concept. Okay. So second law is what? The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a light of a given color and for a given pair of media. This is known as Snell's law, right? So sine of angle of incidence, I can write sine A, and sine of angle of refraction, I can write sine R. Correct? Sine, we write sin, and angle of incidence I. So sine I by sine R is a constant. C is a constant. Okay. For a light, see, you have write this line also for a light of a given color and for a given pair. These are extremely important. Anyway, I'll discuss about all this later on, but these are extremely important. You have to write this condition also for a light of a given color, because when the color changes, right, the wavelength changes, and when wavelength changes, speed also changes. That is why that is very important. Okay, I repeat, light of a given color is very important because when color changes, the wavelength changes, and when wavelength changes, speed changes. That is why that is important. And for a given pair of media, why that is important? Because when media changes, the speed will change. Speed will be different. That is why for a given pair of media is fixed and light color is also fixed. Then only this will work. Otherwise, it will not work. Okay, that means you'll get a different constant. Okay, you'll get a different value. Okay, ratio will become different, maybe 5. Okay, suppose you choose water and glass and light is red color. You'll get some constant, maybe 5. For example, I'm saying. But if you choose a yellow color, no, it will not be 5. It will be some other value, maybe 6. Maybe I'm just giving some random value to make you understand. That's all. Okay. So for a light of a given color and for a given pair of media, these are extremely important. You have to write those two things also. Okay. Yes. See, anyway, earlier when I was teaching this chapter, trigonometry was not taught, so I had given some introduction. All these things is not required right now. I'm very sure you are all aware of trigonometry right now. Okay. So now, so we know that when light travels from a rarer to a denser, it is going to bend towards a normal. So ratio of sine of angle of incidence to the sine of angle of refraction, this is angle of refraction, this is angle of incidence, is going to be a constant. Then it will be C1. C1 is some value, maybe 2, 1.5, 6, anything. Okay. So it has been found that that constant, this ratio is going to give us a value, right? That constant is also equal to refractive index, mu. Okay, mu, we call it as mu. That constant is also equal to refractive index denoted by the symbol mu. Okay, see, this is called as nu, like you'll have something like this. This is called nu. This is mu. Okay, mu. Okay, so that constant is also equal to refractive index represented by the symbol mu. And now whenever we are calculating refractive index, right, we calculate refractive index of a medium with respect to some other medium. We always calculate the refractive index of a medium with respect to some other medium. So here, light is traveling from water to glass. So refraction takes place in glass. Light is traveling from water to glass. So refraction takes place in glass. So we'll find the refractive index of glass. Wherever refraction takes place, no, For that medium only we'll find refractive index always. Okay. So ratio of sine of angle of incidence to the ratio of sine of angle of refraction is a constant, and that constant is also equal to refractive index represented by the symbol mu. Refractive index of what? Wherever refraction takes place in glass. So refractive index of glass with respect to water, because light comes from water. Light is traveling from water to glass, right? So refractive index of glass with respect to water. Okay. So refractive index of glass with respect to water. Okay. Now that is also equal to, that is refractive index of glass with respect to water. We know that sine of angle of incidence to the sine of angle of refraction is a constant. That constant is equal to refractive index of this of glass with respect to water. That is also equal to velocity. V is what? Velocity or speed. Velocity or speed. See, both are same. Whenever light travels, see, we know light travels in a straight line. We know light travels in a straight line. Whenever a body is traveling in a straight line, no, velocity and speed both are same. Whenever a body is traveling in a straight line, speed and velocity both are same. And because light is traveling in a straight line, speed and velocity both will be same. Okay. So if you want, you can use speed word or you can use velocity. Both are same. Okay. If you want, you can use velocity also. No problem. So refractive index of glass with respect to water is what? Velocity of light in water by velocity of light in glass. Okay, so speed of light in water or velocity of light in water by velocity of light in glass. Please remember, first this will come and then this will come. Okay, refractive index of glass with respect to water is what? Velocity of light in water by velocity of light in glass. This will come, then this will come. Okay. So how do we read this one? How do we read this one? Refractive index of glass with respect to water. That is velocity of light in water by velocity of light in glass. Only if this thing is very clear, then only we can move ahead. If this itself is not clear, no, you will not understand anything. Okay. You should remember that we calculate refractive index of a medium where refraction takes place. So refractive index of glass with respect to water is VW by VG. Okay. See, VW means not velocity of water, velocity of light in water. VG is not velocity of glass. Glass will not move. Light will move in glass. Okay. Some people, they will say velocity of glass. Velocity of water, they will say. It's not like that. Okay. So suppose you take, see, now light is going from glass to water, right? So we'll calculate refractive index of water with respect to glass. So see, right, ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That constant is a different value, C2. That is mu refractive index of water with respect to glass. That is Vg by Vw. Vg by Vw. Okay. I hope you are able to understand. So I have given a lot of examples here. Look here. Suppose light is coming from, okay, light is going from 2 to 1, for example. First of all, it is going from 1 to 2. First of all, light is going from 1 to 2. Okay. So refraction takes place here. So we'll find refractive index of 2 with respect to 1. That is V1 by V2, right? First this will come, then this will come. Now suppose light is going from 2 to 1. So we'll calculate refractive index of this with respect to this. So mu1, 2. That is V2 by V1. First this will come, then this will come. Okay. So if you simplify, you will find that refractive index of medium 2 with respect to 1 will be refractive and it will be the reciprocal of refractive index of medium 1 with respect to 2. Okay. See, I have actually derived it here. That refractive index of 2 with respect to 1 will be reciprocal of refractive index of 1 with respect to 2. Okay. Remember this very important relation. That means refractive index of glass with respect to water will be a reciprocal of what? Refractive index of water with respect to glass. Like that. 2, 1, 1, 2. Reciprocal. 2, 1, 1, 2. Here GW, WG. How do we read this? Refractive index of glass with respect to water. Reciprocal of refractive index of water with respect to glass. Okay. Another example. Light is coming from here to here. Wherever refraction takes place, for that only we'll calculate the refractive index. Okay. So refractive index of 4 with respect to 3, that is V3. V3 by V4. V3 by V4. Look here. See, light is going from 5 to 6. So refractive index of 6 with respect to 5, that is V5 by V6. Okay. Okay. I hope you're able to understand. Light is going from 1 to 2. So mu 2, 1, because refraction takes place here. So that is V1 by V2. Okay. Next, there's something called as absolute refractive index. Absolute. See, when light is coming from air, no? When one of the medium is air, when one of the medium is air, and we are finding the refractive index with respect to air, then the refractive index of a medium with respect to air is called as absolute refractive index. Okay, so absolute means we are going to measure the refractive index of a medium with respect to air only. Okay, so that means here refractive index of glass will be absolute because we are taking from air, no? Light is coming from air. But if you look here, look here, water and glass. So here refractive index of water will not be absolute. Why? Because light is coming from glass. So when light is coming from glass, so we are finding refractive index of water with respect to glass, no? So it is relative. This is relative refractive index. So whenever we are going to measure the refractive index of a particular medium with respect to air, it is going to be absolute. Otherwise, it is going to be relative. I hope you are all able to understand. It's very simple. Okay, it's very simple. So I have given the definition also. So refractive index of a medium with respect to air or vacuum. See, both are different, air and vacuum, but in our syllabus, both are same. So we can write anything. Vacuum means there's nothing. Air means some particles are there. Okay. So the refractive index of a medium with respect to air or vacuum is called as absolute refractive index. So I have drawn one diagram and I've actually explained. So here, see, suppose we are finding refractive index of medium 2 with respect to 1. So that is V1 by V2, right? Now, mu21 is what? Mu21 is absolute, right? Yes. So we need not write this one. This is not required. We can just write mu2. Mu2 means what? Mu2 means refractive index of medium 2, which is absolute. Whenever nothing is mentioned, no, with respect to, it is always absolute. Whenever they have not told with respect to what, it is absolute. Okay. By default, it is absolute. By default, it is absolute. Always absolute. If it is not given, it is absolute. Okay. Relative means what? The refractive index of one medium with respect to another medium, except air, is actually called as relative refractive index. For example, here diamond and glass I have taken. So that is relative refractive index. Because we are finding refractive index of diamond with respect to glass, so it is relative refractive index. Okay. Next, I have done some questions. First, we'll go through these questions, and then I'll give you some questions you can actually practice. Okay, we'll practice together. Okay. So first question. All of you first listen. When I'm explaining, no, don't be busy in doing. Then again, you'll ask doubts. Okay. First, you listen. Wherever you go, you do follow this practice. I mean, first of all, you listen to the teacher, and then you do whatever you want. Okay. Calculate the refractive index of material of glass slab. We have to find refractive index of material of glass slab, given that the speed of light through the glass slab is this much and air is this much. So there is a glass slab. We have to find the refractive index of glass slab. Now we have not seen refraction through glass slab, right? That we'll see in the next chapter. So generally, no, when I teach, I do the comparative study of the refraction through glass slab and prism. That is why I teach refraction through glass slab in the next chapter. Okay. So everybody would have got the schedule. See, we are going to follow the schedule, and next class, I'm going to enable the waiting room. So if anybody is actually joining late, you will not be allowed to join the class. So because if you join late, no, you will not be able to understand anything. And then you will disturb. You will say that no, not understood, not understood. I know that you will not be able to understand. Okay. So please, everyone, if you want to attend, you be on time. Otherwise, you don't join. Okay. So this is a schedule. I will share on my screen. Just 1 minute. This is a schedule. The link is going to remain the same. So today evening also we have a class from 6 p.m. to 9 p.m. And when I say 6 p.m., that means 6 p.m. I will start. You should not join at 6 p.m. You have to join 5 minutes before. Wherever you go, this is the practice. 6 p.m. when the class is at 6 p.m., will not join at 6 p.m. But majority of the people they will join at 6 p.m. In spite of repeating, they will do that. Okay. And they will say, sir, network issue, sir. I was trying to join from before 10 minutes itself, sir, then I was not able to join. So network issue, that is why I'm not able to join. They will say like that. Okay. See, even I can give those excuses. Okay. And even I can switch off my videos. And anyway, I don't know. I'm not requesting anybody to keep their video switched on. I'm not requesting anybody to keep their video switched on. But I'm just saying that even if I keep it off, nobody will ask me questions. I mean, why is your video switched off? Nobody will ask. Okay. So wherever you go, right, if someone is instructing something, try to follow that. Okay. You can keep your video switched off. I don't have any problem. Okay. Anyway, it's revision, so it's okay. But if somebody is instructing something, try to follow that. Whether other people are doing it or not, you leave that. Okay. You have not joined because of other people, right? You have joined for yourself. So do what is good for you. That's it. Okay. So today 6 p.m. to 9 p.m. we'll be revising electricity. Okay. Please start joining by 5:55. From 5:55, 6 o'clock sharp will start. Okay. Perfect. So let me share my screen. Okay. So we have to calculate the refractive index of this glass slab, right? Now they have not told with respect to, right? They have just told calculate refractive index of glass. They have just told calculate the refractive index of material of glass slab. With respect to that, have they given? No. That means it is absolute, which we have to find out. That means we have to find the absolute refractive index. Yes. So refractive index, how do we denote? Mu, right? So refractive index of glass, nothing is given means air, no? With respect to air. Refractive index of glass with respect to air. In terms of velocity, how can we write? VA and by VG. Okay. Now, to find the refractive index of glass with respect to air, we can find the ratio of velocities. Velocity in air, velocity of light in air is given as 3 into 10 to the power 8. And velocity of light in glass is given as 2 into 10 to the power 8. Okay, it will become 3 by 2 is half. Oh, sorry, 1.5. 3 by 2 is 1.5. Okay, so the answer is 1.5. I hope you have understood. It's very simple. Okay, it's very simple. Okay, next question. Calculate the refractive index of light in water. Calculate the speed of light, sorry. Calculate the speed of light in water of refractive index 4 by 3. See, they are saying water of refractive index 4 by 3. See, here they are just giving refractive index of water, right? With respect to have they given? No. That means that is refractive index of absolute refractive index of water. That means this is absolute refractive index of water. Whenever nothing is mentioned, it is absolute. Okay? We have to calculate the speed of light in water of refractive index 4 by 3. That means they have given refractive index of water with respect to air, because nothing is mentioned, it is absolute. So that is what? VA by VW. Yes or no? Given that speed of light in air is this much. So VA is given. Now this is also given, right? Refractive index of water with like absolute is given, right? 4 by 3. So 4 by 3 is equal to 3 into 10 to the power 8 divided by VW. Cross multiply, you'll get the answer. Check everyone. It's so easy. Check. Check all of you. It's actually very, very easy. Okay. It's very, very easy. Okay. First of all, we take this to the left side, this one here, and this one will come down. These are all basic maths. Okay. You should know how to solve all this. Okay. Next. Look at this question. Very important. The refractive index of glass. Have they told with respect to what? No. That means it is absolute. Refractive index of glass is 1.6 and that of diamond is 2.4. So refractive index of glass, that means it is absolute. Okay. So nothing is mentioned means it is absolute. Okay. So refractive index of glass is 1.6. So glass with respect to air only, right? So can I write VA by VG? VA by VG I can write. That is 1.6. Next, refractive index of diamond. So diamond is 2.4. That is again with respect to air. So I can write VA by VD. See, this A and all is optional. If you don't write also, it's okay. Okay. So mu G is VA by VG and mu D is VA by VD. Okay. Yes. What we have to find out? Calculate the refractive index of diamond with respect to glass. So refractive index of diamond with respect to glass. So in terms of velocity, I can write VG by VD. Na? VG by VD we can write. That means to calculate the refractive index of diamond with respect to glass, we can find ratio of these two. Yes. To calculate the refractive index of like diamond with respect to glass, we can find Vg by Vd. Yes. Now, where will you get Vg and Vd? See, we have got two equations, right? This is equation number 1. This is equation number 2. If you simplify, we can get Vg here. Vg is equal to, like, if we have 1.6, see, this is 1.6, Va by Vg. So cross multiply, you'll get Va is equal to this much. So Vg we can find, Vg will be 1.6 will go down. So Vg is equal to Va by 1.6. Same way, 2.4 into Vd is equal to Va. So Vd will be Va by 2.4. You put Vg and Vd value and simplify, you'll get the answer. This is just one of the approach. This is just one approach. We can solve question by any other way also, but this is just one of the approach. It is much simpler actually. Okay. You just find Vg and Vd from the two equations, you substitute, you'll get the answer. This approach is much easier. Okay. Now, if you want to do some other approach also, you can do it. Okay. Next, look here. The refractive index of glass is 1.6 and that of diamond is 2.4. Calculate the refractive index of glass with respect to diamond. So glass is given 1.6, that is Va by Vg. Diamond is 2.4, that is Va by Vd. Okay, we want to find refractive index of glass with respect to. So actually, I have told one shortcut here. This shortcut, you don't follow shortcut. This is actually shortcut. Okay, you look here. Refractive index of glass with respect to diamond, okay, is Vd by Vg. Correct? That means get Vd and Vg and substitute, you will get the answer. Simplify. Please don't follow the shortcut. If you follow shortcut, they will not give full marks. Okay, you may not get any marks. It is only for MCQ. Okay, we can do it. See, earlier I got the answer as 3 by 2, right? Why we got 3 by 2? See, here actually dg, right? Mu dg. So if it is gd, it will be reciprocal of this. See, refractive, we know, right? Refractive index of diamond with respect to glass is reciprocal of refractive index of glass with respect to diamond. So if you want to find glass with respect to diamond, we can take reciprocal. But first of all, we have to find this, right? But if this question is asked independently, I mean, we cannot do like this, right? We have to do step by step like this, right? Yes. This question has been asked many times in the exam, many times. Okay. So the refractive index of a medium X. So maybe this will alone, shall I do it? Okay, we'll go through it. I'll give you another question. Okay. So refractive index of medium X with respect to Y is 2 by 3. So refractive index of medium X with respect to Y is 2 by 3. So in terms of velocity, can I write Vy by Vx? And refractive index of medium Y with respect to Z is 4 by 3. That is Vz by Vy. Yes. What we have to find out? Refractive index of Z with respect to X. Refractive index of Z with respect to X. That is Vx by Vz. Correct? That means you just have to find Vx and Vz from the two equations, substitute, get the answer. That's all. How will we get Vx? We can get Vx from here. You have Vx here, no? Simplify, you'll get Vx. How will we get Vy? Sorry, Vz. Vz we can get from here. We have Vz, no? Simplify, you'll get Vz. Put Vx and Vz value, simplify, you'll get the answer. So simple. Okay. Look here, if somebody is having a confusion how to get Vx value. See, they have given 2 by 3 is equal to Vy by Vx. We want to get Vx, right? So cross multiply. So put Vx here. Next, we need only this Vx, right? 3 you take to the top and 2 you take to the bottom. Why? Because when something is down, if it goes to the right side, it will become top. It will become multiply basically. This will become divide. So that is why it will become 3 by 2. Same way here. Take it to the left side. We need Vz, right? So directly we have got Vz. Actually, directly we have got. Just by cross, like taking this side, we have directly got. You put the value, simplify, you'll get the answer. Okay, so simple. If anybody is having a doubt, you please ask. Next, I have done this question also. Check everyone. Just check this question once. And next part of the question was, if the speed of light in medium X is this much, calculate the speed of light in medium Y. So speed of light in medium X is given. We can find speed of light in medium Y by using this relation. That's all. Just check everyone. I'll give one question. You can try. It's very easy, but okay. For 5 marks, they're asking questions from this topic. So please practice. Sometimes 4, sometimes 5, depends. Okay. Please don't search anywhere. Whatever question I'm going to give, do it by yourself sincerely. Okay. You don't have to give the definition. Definition already I've given you. Okay. Try the second question. See, ignore this question. You ignore this question, try this question. Okay. And then try this question. Do it in a notebook. This question you ignore because this we'll discuss later on. Okay. You ignore this question. You try these two questions. Do in your notebook. No need to put in chat. Let's understand. It says absolute refractive indices of water and glass are 4/3 and 3/2 respectively. They have given refractive index of glass with respect to air. Sorry, first of all, water they have given. They have given refractive index of water with respect to air is 4/3. So generally, when air is there, no, we don't write this one. We just write mu W. That's it. The refractive index of glass with respect to air is 3/2. In which of the two media is the speed of light more? See, higher is the refractive index, more is the optical density. That means particles will be much closer. More the refractive index means particles will be much closer. That means it will be denser. Okay. So if you look here, the refractive index of water is less. The refractive index of, like if you simplify, right? 3 ones are 3, 3, and then we got 1.33 like this, we'll get 1.5. Okay. So if you see refractive index of water is going to be less. So in which of the two media is the light of speed of light more? The speed of light is more in water. If you want, you can write reason also because the refractive index of water is less as compared to glass. Okay. Next, if the ray of light enters obliquely means inclined at some angle. Obliquely means at some angle. So if a ray of light enters obliquely from glass to water, light is going from where? So glass to water. If the light enters obliquely from glass to water, will it bend towards normal or away from the normal? See, glass is denser and water is rarer. So denser to rarer, it will be bend away from the normal, right? So the answer is bends away from the normal. Okay. Next. Just 1 minute. Just 1 minute. Okay, let's do it. I'm sorry. Okay. So it says the absolute refractive index of water and glass are 4/3 and 3/2. Okay. If the speed of light in glass is this much, find the speed of light in water and vacuum. Okay. So what they have given, absolute refractive index of water is nothing but 4/3. So that means in terms of velocity, I can write VA by VW, equation number 1. And refractive index of glass is nothing but 3/2. That is nothing but VA by VG. Yes or no? So now, if the speed of light in glass, so that means Vg is given. Vg is 2 into 10 to the power 8. Yes, meter per second. Find the speed of light in water. See, if you want to find the speed of light in water, that is this much, this one, right? Vw is only the speed of light in water, right? If you want to find this, you should know this. If you want to find this, you should know this. But it is not given in the question. But we know speed of light in air is 3 into 10 to the power 8. We know that. But we will not substitute. Some teachers, they will not give marks if you do like that. Why? Because, see, there's another equation wherein they have given Vg, so we can find Va. Yes, that is why they have asked no vacuum. So please don't do this first. You have to find this first. Although in the question they have asked water first, but we have to find vacuum first, then only we have to find water. Please remember. Okay. We have to find vacuum first. Actually, in the answer key also, they have found vacuum first. But I don't know why they have given question like this. I mean, first of all, they have given water and then they have given vacuum. But we have to find vacuum first. We have to find velocity of light in vacuum first, and then only we have to find velocity of light in water. Okay. So how do we actually find the velocity of light in vacuum or air? You have this substitute, simplify. Like, see, look here. 3/2 is equal to VA by 2 into 10 to the power 8. Cross multiply 2 into 10 to the power 8 into 3/2. 2 gets cancelled. So 3 into 10 to the power 8. This only is the value, we know that, but still will not use. Now put VA value here. So 4/3 is equal to 3 into 10 to the power 8. VW. We want to find VW, cross multiply. So VW is equal to into 3/4. Okay, 4 will come down, 3 will go here. So that means 9/4 into 10 to the power 8. So 9/4, now if you divide, actually you'll get 2.4 to the 8 and 4 to the 8. 2.25, 10 to the power 8 meter per second. Okay. 9/4 if you do. 4 to the 8, 1. For decimal point, 0. 4 to the 8. Okay. 2 and 4, 5 is the 20. 2.25 will get. Okay. 10 to the power 8 meter per second. I hope everybody has understood. With this, somebody has asked a question. Is it constant? Then no. Although it is a constant, we cannot write directly. Okay, please, all of you, please remember this. Although it is a constant, we cannot write it. Here we cannot do it because that is why they have asked vacuum first. Like that is why they have asked vacuum, right? Although it is a constant, we'll first find this one, vacuum, then only we'll find for air. Understood, Vaishnavi?
Yes, sir.
Okay. So with this, we'll stop. If anybody's having a doubt, you can wait and ask. If you don't have a doubt, you can leave. Thank you so much, everyone, for joining in. Take care. Bye-bye. And have a great day ahead. We'll actually be meeting again at 6 o'clock. Thank you. Bye-bye.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir. Bye, sir.
Thank you so much, everyone.